All right, here we go. You ready, Alon? You ready for this? If anybody wants to throw out some random lyrics that you want me to sing, just put them in the chat. Well, here we go. Alon is the VP R&D at Aporia, writing code from the age of 7. He has an unhealthy obsession with programming and a huge love for mixing engineering with data science. Mixing engineering with data science. When he isn't coding, Alon enjoys playing video games and musing about biology. Alon is the VP R&D at Aporia, writing code from the age of 7. He has an unhealthy obsession with programming. And that's all we got, because we're going to get right into it right now. I'm going to hand it over to you, my man. Alon, here we go.
I didn't know you were playing the guitar.
Oh, that was a little surprise that I had up my sleeve for you. And I figured you did all this work by creating these GitHub repos that we can all follow along to. And so I got to do at least a little bit of something. Yeah. There we go, man. So I'm going to hand it off to you. Like I mentioned before, because there's a few new people that just joined us and probably were wondering what that whole song was about. We are doing a 2-hour coding session right now. This is a workshop, 2-hour workshop. If you do not have the time to stay the 2 hours, you can catch up with this on YouTube. It will probably be posted on Friday, if not Friday, Monday. And feel free to ask any questions you want in the chat. I will stop Alon at the adequate times to ask him those questions. So if you need anything clarified, just go ahead and throw it in the chat. And who knows, maybe somebody else in the chat can help us. All right, that's what we got. Alon, it's all yours, man.
Cool. So we'll do a quick introduction. And I think that after some, like just 5 minutes of talking, we'll jump right into the code, because that's what we came here for. So here's the story. So when you have 1 or 2 data scientists in your organization and they start working on new projects, you probably focus less on your ML infrastructure, right? But when you have more data scientists, or when you start deploying models to production, then the need for proper ML infrastructure become crucial. And there are different needs for infrastructure across the ML pipeline. I'm pretty sure you know them, for managing experiments and data versioning and deployment and monitoring models and many more. And basically, leading companies in the field with like massive engineering teams like Uber and Netflix and Airbnb had created like multiple solutions for their infrastructure and named the combination of them as ML platform. So today, what I want to do is to focus on the structure of an ML platform and how can you build it by yourself. Cool, so let me share my screen, just 1 second. Can you see my screen? Okay, so yeah, so basically, like this is a really typical, pipeline for an ML platform, ML workflow. You have your data collection and versioning. Sometimes you have a feature store, training orchestration, experiments management, packaging and deployment, model serving, so on. And maybe some of these problems are relevant to you. Maybe some problems are completely irrelevant to you. Maybe you have other problems that are relevant to you but are not written here. So when designing your ML platform, it's super important to deeply understand your needs and your problems, make a prioritization, and choose the best solution for each problem. So today, what we're going to do is to focus on these problems, on the data versioning, the experiments management, deployment, and serving problems. We're going to build this on top of AWS, but it could work for Azure, Google Cloud, or any other cloud provider as easily. And we are going to use the following tools. So we are going to use DVC for data versioning. We're going to use MLFlow for experiments management and packaging and deployment. And we're going to build model servers. We're going to serve our models through an HTTP server based on FastAPI, which is a Python framework similar to Flask. So yes, but it's really important that when you design your own ML platform, don't just pick DVC because that's what we did in this session or something. It's really important not to take these tools for granted and evaluate the alternatives. So I've written here some alternatives in each category. For example, we have Pachyderm and Weights and Biases, and we have CometML and Neptune. We have many, many tools. And yeah, it's important that to evaluate your problems and your needs, to choose the best solution, the best tool for the job at each time. So to help you choose between different tools, we released today a website, an open source website. Let me show it to you. So this is a quick website that we did. Basically, it compares many MLOps tools categorized to different segments of this universe. So for example, we can click on model serving, and we can see here Bento-ML and Bodywork and KFServing. And this website is completely open source. So it's on GitHub. So we'd love your contributions if you have any. And yeah, so let's move. Okay, so let's continue. So I'm going to do a quick recap on the basic technologies that I'm going to use. And then we will talk about the architecture and get into coding. So let's talk a little bit about Kubernetes. So let's say you have a traditional operating system like Windows or Linux or Android or Mac OS. So usually it runs on one machine, on one computer, right? And on top of that machine, you run applications. So this is a traditional operating system. And I like to explain Kubernetes in a way, it's pretty similar to an operating system. So in this case, we have Kubernetes, but it's not running on one machine. It's running on multiple machines. And the idea is that you can add more machines or remove machines when you need it, when you need them. So for example, if I run, let's say that I have this model and it runs on this machine, and suddenly I have a lot of predictions, and suddenly I have too much, for example, too much resource usage. For example, let's say that I'm out of memory. So in a traditional, if you just install the model server on traditional machine, traditional operating system, you wouldn't be able to do much about it. But in Kubernetes, you can just keep adding more machines and keep adding more computers, and that's how you scale and make it much more reliable. So applications that run on top of Kubernetes are almost all the time, usually based on Docker, these are containers. And I can make replicas of them. For example, I can take this application and run it multiple times. Yeah, so to install a program on a traditional operating system, usually you would run something like sudo apt-get install my app, for example, in Ubuntu. In Android, you would, I don't know, you have the Play Store. And Kubernetes, has multiple methods to install. There are multiple methods to install applications on top of Kubernetes, but I think the most standard one and the one that we will use during this session is to use Helm. So Helm is simply a package manager for Kubernetes. So I can run Helm install my application, Helm install, for example, MLFlow, and this way I can install applications on top of Kubernetes. So just to clarify, Kubernetes isn't really an alternative to a traditional operating system, but like most of the times you do have Linux installed on those machines, but it helps, at least to me, it really helps understanding what it is exactly. So we're going to use the following services in AWS. So just want to make sure that, that we are aligned on them. So we have S3. S3 is basically a file storage. It's a managed file storage. And each instance of this, each disk is called a bucket. So I can, for example, create an S3 bucket for my models, S3 bucket for my data, etc. Etc. Another service that we're going to use is EKS. So EKS, I just explained what's Kubernetes. So EKS is basically managed Kubernetes. Like AWS take care a lot of like maintaining that, like the control plane of that Kubernetes. Another service that we're going to use is RDS. So RDS is just the name in AWS for a managed database. And specifically, we will use Postgres. Postgres is it's extremely popular SQL-based database. The last service that I want to mention is Route 53, which is a DNS provider. If you don't know what's DNS, it's simply, this service will simply allow us to use the domain ML.Aporia.com. Obviously, when you build your own ML platform, it won't be Aporia.com. This is just my domain, but we're going to use Route 53 to make sure that this domain is routed to our ML platform that we're going to build. Any questions so far? Okay, so so let's talk a little bit about the architecture of what we're going to build. So let's say you have your data scientist who wants to start a new project. So what we're going to do is to build a template for him. This template will include a very, very simple model, LightGBM-based model. I'll show it in a second. So data scientist wants to start a new project. He simply clones this template, and then he can start training his model, experiment with it, changing the data set, etc. So we are going to use a tool called Cookiecutter, and I will show exactly, I will explain more about it later in the session. Okay, so our data scientist plays with the parameters, and eventually he has a model. So we are going to use MLFlow for tracking the experiments that it does there. So so MLFlow, we're going to install it on top of Kubernetes. We're going to have, I think, 3 machines for this Kubernetes, and we're going to install MLFlow on top of it. And each time the data scientist will train his model, the model will be sent to MLFlow. So MLFlow uses 2 types of databases or storages. The first type is the artifact storage. So the artifact storage is where MLFlow saves all the models, the files of the model themselves. So we're going to create an S3 bucket. Again, S3 is the file storage in AWS. And we're going to create an S3 bucket for that and connect that to MLFlow. Additionally, MLFlow uses, it needs a database for storing the model metadata. For example, relevant metrics and history of the experiments, and etc. So we're going to use Postgres. Postgres, again, it's the super popular SQL database that I mentioned earlier. Cool. So yeah, so we have the model. We have the model. So we have the model sent to MLFlow. And then we're going, so this is mostly the dev part. Let's talk a little bit about the production part. So the idea is that we are going to have a FastAPI server for each model, and we run those servers on top of Kubernetes. So in this case, we have 3 FastAPI servers, model 1, model 2, model 3. And all of these services, all applications that run on top of Kubernetes are not exposed to the internet automatically. You need to take care of that. So in order to take care of that, we're going to use another Kubernetes application called Traefik. So Traefik is an API gateway. And what it does is basically just expose other applications to the internet. So the idea is that we have, for example, we're going to, let's say we have this web application that wants to make a prediction. It will send an HTTP post request to our ML platform, this predict, and we have this JSON here. And then it will get routed to Traefik. Traefik will know since the URL starts with /my-model, it will know to route that to the specific FastAPI server. So we will see all that later on this session. Just one more thing that I want to mention is that while training the model and experimenting with data, it's super important to save the data set across versions, the data set across time. So if I have a problem later on, I can go back in time and see what's the data set that I trained the model on. Cool. So this is the architecture that we're going to build. So when you're building infrastructure, so I'm getting to coding in less than a minute, I think, but when you're building infrastructure, for example, when you want to create a new database in AWS, for example, but this is pretty much relevant for all cloud providers, you have a really complicated screen with a lot of different options. And yeah, actually, let me tell you a funny story. One time, I think I changed this value to something that I did. I missed it or something like that, and suddenly we had like a $6,000 bills on this database. So only on that. So it's super complicated and it can make a lot of issues. So instead of defining our infrastructure from the UI, we are going to use a concept called infrastructure as code. Specifically, we're going to use Pulumi for that. So another option, by the way, is Terraform. Terraform and Pulumi are, I think, 2 competitors, and they're doing mostly the same thing. Specifically for this session, I chose Pulumi, but you should definitely check out Terraform if you are building your own ML platform. Yeah, so the idea is this. Instead of defining your infrastructure in the UI, we're going to write code that represents that infrastructure. For example, we have this line of code here, and this line of code basically represents a Kubernetes cluster. EKS, again, it's the managed AWS service for Kubernetes. Another example is this S3 bucket. We have this artifact storage, and basically we define all of our infrastructure in code. So let's say I wrote this code, and then I run the command Pulumi up, and then Pulumi will simply create all that infrastructure in my cloud provider. So that's pretty cool. Let's say I comment out one of those lines. Then I run Pulumi up again. It will know to remove that resource from the cloud. And if I make a small change to a resource, then Pulumi will know to make that change actually in the cloud. So every change to the infrastructure this way can be code reviewed. For example, you can manage it in source control. You know how your infrastructure looks across the history. and you're much less prone to mistakes. Now, I'm sure there are a lot of memes about it. That in the MLOps world there are a lot of tools to choose from, for every category. But I believe that infrastructure as code can really help you iterate and play with different tools, and therefore make a better decision of how you build your ML platform. Cool. So just two things before getting started. So this is going to be a real live coding session, and there might be some bugs that we'll need to investigate in real time. But that's part of the fun. And we are going to cover a lot of details really, really fast. So if you don't understand something, don't worry about it too much. Ask in the chat. The high-level picture is much more important, not the specific. For sure, there will be specific line of code or something that will be less clear. But again, the high-level picture is much more important. Okay. So I've prepared two GitHub repos. The first one is called ML-Infra, and the second one is called model template. So the ML-Infra repo will use it for all the shared infrastructure of our ML platform. For example, let's go back to the architecture. So for example, in this ML-Infra, we're going to have a Pulumi project that will set up this Kubernetes and RDS and S3 and MLFlow, because MLFlow is shared with all the models, shared infrastructure. So that's going to be our ML-Infra repo. The second repo is going to be the model template repo, which is going to be the template that data scientists can clone and build their models on. So we are going to have an example model here. Specifically, it's going to be, I chose this data set, the Iris data set. It's really popular, very simple. Basically, it classifies different types of flowers. We have the length and the width of each part of the flower, and it classifies it to a specific flower. And the model training code is going to be based on LightGBM. So to not waste time, this is just normal IGBM training code. So I will just copy paste that. Yeah, so that's going to be our model template repo. Okay, so let's get started. Any questions so far?
Yeah, just there's a quick one from Aruna. To try this demo, what are the prerequisites for AWS?
So you basically need, all code will be open source, and to run this code, you'll just need an AWS account, basically, and configure. Yes, yeah, I will open them up. Yes, so you basically all you need to do is just to run Pulumi app on these repos, and it will set up all the infrastructure for you. So that's part of the magic of Pulumi. And yeah, these repos are currently private, but I will open them up right after the workshop. Any other questions?
I think that's it. Looks good.
Cool. Okay, so let's clone this repo. Let's start from the ML-Infra. I'm going to start from setting up this Kubernetes and this database, this RDS database. So spinning them up can take around 10 to 20 minutes. So I'm going to write the code for spinning them up, then continue and build other stuff. So let's start again from this database and this Kubernetes. Okay, so let's clone the ML-Infra repo. And I'm gonna cd into it and create a new Pulumi project. So basically, all you need to do is something like this: Pulumi new. I'm gonna use --force because basically it assumes you have an empty directory, but there are some git files. Never mind. And I'm going to choose this template, this starting point. Basically, we're going to code our Pulumi code in TypeScript, and we're going to use AWS. So let's call this ML-Infra, shared infrastructure for our ML platform. This is just a product description. We'll go with the default here.
Alon, can you zoom in so that the font is a little bit bigger?
Zoom in. Yeah, I can do that.
There we go. Perfect.
Cool. So basically this script now installs the dependencies of Pulumi, and right after that we'll open that in VS Code and start coding. Just 1 second. Cool. So let's open this project in VS Code. And we have this index file. This is where we're going to write most of our infrastructure. Delete the default thing here. OK, so the first thing that I want to do is to set up Kubernetes. So let me show you how easy it is. All you need to do is Google Pulumi AWS Kubernetes. I'm going to just go to the first link. And I'm just going to copy this example code. I will need to install this dependency. Let's do that. I will open the terminal here. Okay, so this is how you install dependencies. And that's right here. Add a comment, create Kubernetes cluster. And we'll call this the ML cluster. So basically, that's it. We are going to pass it one parameter that I will explain later why we need it. It's called provider true. But basically, when we are going to run Pulumi, this Pulumi lecture to create that Kubernetes cluster. Cool. So basically, by the way, when you do set up your own ML platform, it's really a good idea to go to the documentation and read about the different parameters and etc. But for our case, for this workshop, a really simple cluster will be enough. OK, so the next thing that I want to do, so this should set up this part, this Kubernetes, that we're later going to install MLFlow and our models. And now we're going to set up this model metadata database. So again, let's just Google Pulumi, AWS, PostgreSQL. And let's go to the documentation and just copy the example. So create PostgreSQL for model metadata. Okay, so we have this database. Let's call it MLFlow DB. Every object in Pulumi has the first parameter is always the name of the resource. And let's change the parameters a little bit. We want more than 10 gig. This is gigabyte. So this is the amount of storage in this database. We are going to use Postgres. We'll need this version, and we're going to use this instance class. The name of the database is going to be MLFlow. We'll remove this. This is the password of the database. And this is the username. We'll just use Postgres. So let's be a little more secure than that. I mean, foobar is not such a good password. So what we really want to do is to use a really secure and strong random password. The problem is, and this will help emphasize what Pulumi does exactly. I'm going to run Pulumi up soon. And this will execute this code and then create those resources in AWS. So if I would just do something like that, if I would just use TypeScript random function, then each time that I run Pulumi up, it will generate a new password, which is, of course, not what we want. We want to generate a random password one time. So Pulumi provides a way to do this. Just Google Pulumi random password. And again, just copy the code. Let's do that. The import should be above. So everything is under this comment here. And we don't want any special characters. This will essentially create a random password with 16 characters in length. Let's call it MLFlow DB password. And let's use it here. Okay, so let's go back to the architecture for a second. Okay, so we are going to run MLFlow on top of Kubernetes, and this MLFlow will need to access the database that we just defined in Pulumi. So we need to make sure that Kubernetes has access to this DB. To that, I'm gonna change the security group of this database. Basically, that's pretty much AWS thing, but you need to do this once. Let's make sure that our EKS cluster has access to DB. EKS, again, it's the managed version of Kubernetes in AWS. Yeah, so let's define those security groups so the cluster will be able to access it. Cool. So now after this line, like when we spin up the database and the cluster, then it should be able to access it. Okay, let's make sure I didn't miss anything before running. Yeah, we'll need to install this dependency as well. Install. Let's see. We're creating a cluster. We have this password here. Postgres. Okay, that looks good. Cool. So the next thing after we wrote those two resources is to actually run Pulumi up and make sure that just let me make sure that we install EKS. Cool. So now we'll run Pulumi up. And this will take between 10 to 20 minutes. We'll continue working, but this should spin up this database and this cluster on AWS. So I think this is a good time to pause for questions, if there are any.
Let's see what they got. I'm not seeing anything coming through in the chat right now, but I was talking to somebody earlier and I was asking them what some of their favorite plugins were that they used. Do you have any favorites?
Favorite what exactly?
Plugins for like your code editor.
Oh, so I have a team member who is really strong in all the plugins for VS Code, but I'm just using the defaults. Yeah, I'm not such a plugin person.
All right. If anybody has some good plugins that I need to know about, throw them in the chat. Also, I'm always looking for cool stuff. The one that I can't remember the name of it, but I was talking to Kyle earlier, and he was saying how he uses for YAML files. He uses a like Rainbow plugin, which helps you when you're writing your YAML files so that you don't make any mistakes.
Cool. It like for Kubernetes YAMLs or
yeah.
just.
Yeah, exactly. All right, so we've got one question coming through here from Carlos. In this case, we're only using one cluster. If there was more than one cluster, can all of this be done via Pulumi and autoscaling?
Yeah, so so you can define here any amount of clusters that you want actually. The power of Pulumi is that you can make that in a for loop. Yeah, so I can do something like this. And just like that, I have just created 100 clusters on AWS, which is going to cost a lot. So I'm going to remove this code very quickly. But yeah, all of this can be done via Pulumi. Although usually you would want just one or two clusters, but you maybe what you want is more machines for the clusters, so you have more resources to run your models and etc. And yeah, this can be defined as a parameter. I think it's called desired capacity. You can tell how many machines you want. And you can also define auto-scaling. So you can tell it something like minimum size 10 machines, maximum size 100 machines, and ideally I would want, for example, 40 machines. So yeah, so just Google Pulumi and Kubernetes auto-scaling. There are a lot of ways to do this.
Was there any specific feature that made you choose Pulumi over Pulumi over Terraform. Yeah, this is actually something that I was thinking too.
Yeah, so I love the fact that you can write these things as in a real programming language, and not like in the Terraform is based on the DSL. It's like they created their own language, and I love the fact that you can just, for example, do things like read configuration from your own format, your own YAML file, and then create resources from that really, really easily. So yeah, that's why I chose Pulumi.
What about Chef or Puppet?
Yeah, so I'm less familiar. I'm less familiar with Chef and Puppet. Sorry, but yeah, but basically, I know that the two main products in the space are Pulumi and Terraform. Okay, so let's continue.
Let's do it.
Sorry?
Let's do it. I'm ready.
Okay, so right now we are running this Pulumi, which creates this cluster and this database. And the next thing that we want to do is to install MLFlow. And before installing MLFlow itself, we will need to create this artifact storage. Again, this is the place that we're going to save our models. And yeah, we already created it. So we'll need to create this artifact storage. So again, this storage is going to be based on S3, which is AWS managed service for file storage. So just like before, I'm going to Google Pulumi S3 bucket. By the way, just to clarify, each one of these, this is a bucket and this is a bucket. I'm not sure why they use the word bucket, but yeah. Okay, so just copying the example here. And let's comment. Let's create the artifact storage for MLFlow. This test, we don't need all those tags, and we do need it to be read-write. So public read-write. The reason is because sorry, let me go back. Yeah, so we are training models. We want to save them to MLFlow, and MLFlow save them in this artifact storage. So MLFlow needs the ability to write to this storage. So let's call this artifact storage. Cool. So the next step is to install MLFlow itself. So let's go back a little bit. Just like you install applications in Ubuntu using apt-get, or just like you have, your Play Store where you can install applications in your Android phone. For Kubernetes, I'm going to use Helm. Helm is the package manager for Kubernetes. So I'm going to Google Helm MLFlow, and this is one of the most important parts of this session, because if I don't like MLFlow and I prefer, I don't know, some alternative, I can just Google that and install it quickly and try and play and evaluate other tools. But we are going to install MLFlow in this session. So this is how it looks. Basically, we add, this is the URL to download MLFlow from, and this is how the commands looks like. So we could run this command on top of Kubernetes, but we want it to be managed through code, right? Because then it can be code reviewed, and we can see history across time and all the advantages that we get from Pulumi in the infrastructure side. We are going to get by writing this as code. So let's Google Pulumi Helm chart. Pulumi Helm chart. So this will install a chart. This will install a Kubernetes a Helm chart. We'll use it to install MLFlow. Let's do that. Install MLFlow. We will need this import. And just so I won't forget, let's install this dependency. Okay. So yeah, so we'll call this MLFlow. This is MLFlow itself, which runs on top of Kubernetes. This should be MLFlow as well. And for the repo, we need to configure the path from here. Yeah, so that's basically how you install a tool, a Helm chart on Kubernetes. So what we need to do is, so let's go back to the architecture. Yeah, so MLFlow talks with this artifact storage and this model metadata database. So we're gonna need to connect MLFlow to these storages that we created here and here. So Helm has a concept called values. Basically, this is like the settings for this chart, for this Helm installation. And in these values, I'm going to configure MLFlow to talk with this artifact storage and this DB. So let's see what settings do we have here. Oh, okay, so this is basically the way to tell MLFlow to talk with the Postgres database. But this is YAML, and we are working in the programming language in JavaScript, so it will be much easier to work with JSON. So let's just Google YAML to JSON, copy paste. So this is the settings in JSON format. Let's copy paste that. Cool, and this is basically the values. This is the username for the database, the password, the host name, etc. And let's use like the information from this database. So MLFlow.username, MLFlow.password, and the host is in address, is in port, and the name of the database is going to be MLFlow. Cool. So okay, so if we go back to the architecture, we just connected MLFlow to this database. Now we need to connect MLFlow to this artifact storage, to this S3 bucket. And so let's see what's the setting for that. Usually you have this table which shows you all the settings for the Helm chart. And as you can see, this is the place to configure the S3 bucket. So let's do that. Copy that. Yeah, so this should be something like S3, then the bucket name. So the bucket name, we can extract it from this. So let's do that. It should be bucket, but we do need to add the S3 prefix, the protocol prefix. So the way to do it in Pulumi is something like this. Okay, so I'm gonna write S3 and then bucket name. Yeah, so basically this is how you concatenate strings, because this is not available on the time of running this necessarily. So you need to do this trick. Cool, so this should configure MLFlow to talk to Postgres and talk to this S3 bucket. Just to make sure I don't forget, I want to install MLFlow on the cluster that I created here. So the way to do it is okay, so we have one more thing before MLFlow is actually installed and working. We need to make sure that MLFlow has permission to talk to this bucket, this storage. And basically, Kubernetes, just like any other operating system, has a concept called users. So we are going to create a new user in Kubernetes that has access to this S3 bucket. So I've created a snippet here. This is a snippet. And basically, that's create a service account. Service account is just another name for a user in Kubernetes. And it will have access to, like, after we will create this resource, then we will have a user in Kubernetes that MLFlow can use and communicate with the S3 bucket. So this is, again, this is completely open source. This is already public. Just a useful snippet that I think they should get into Pulumi itself, because you do this all the time. So I'm just going to copy paste that and import that component. Yeah, so by the way, this is one of the cool things with Pulumi, that you can write your components and then share them. So that's pretty cool. Okay, so yeah, so I haven't, oh, sorry, no need for this extension. Okay, so now let's create that. Let's get the user. Put an example here. So we'll do that before actually installing MLFlow. Let's call this the MLFlow service account. Again, service account is just a beautiful name for, I won't say beautiful, but just another name for a user in Kubernetes. So we use the default namespace, and we don't want this user to be read-only because it's gonna write models to the bucket. And now we need to configure it. So again, I'm gonna go back to the Helm chart settings here. And this is how you configure a service account. So let's do that. We don't want to create a new service account, and we want to use the service account that we just created in Pulumi. Okay, let me make sure that everything is okay. If there are any questions in the meanwhile, this is a good time.
Not seeing anything in the chat yet.
Okay.
I know there's been a lot of questions about people wanting to know where they can get their hands on this code. We're going to make it available after the session so that you can all go and play around with it and try and recreate this beauty. If anybody's got any other questions, let us know. Otherwise, we can keep cracking on.
Cool. Okay, so let's go back to the architecture. So what did we do so far? We wrote Pulumi code for creating a Kubernetes cluster. We installed MLFlow on top of that cluster. We also created this artifact storage and this model metadata. By the way, it's not in the past, like we're going to run Pulumi up and it will do all that stuff. But yeah, so we're going to have we created the artifact storage and the model metadata. And now, basically, after running Pulumi up, we should have MLFlow running on top of Kubernetes. The problem is it's not going to be exposed to the internet. Like we want to be able to access it in our browser, for example. So to expose Kubernetes applications to the internet, we're going to use Traefik. So again, Traefik is software that allows us to expose this MLFlow and these servers later on to the internet. So Traefik itself is also a Kubernetes app. And the way to install Kubernetes applications, I won't call it their way, but one way to install Kubernetes applications is to use Helm, just like we install MLFlow. So let's do that. Let's Google Traefik Helm chart. And here's the command, actually, Helm install Traefik, and this is the repo URL. So we already know how to do this. Let's copy this chart. We're now going to install Traefik. By the way, the previous Pulumi app just finished, and we should have the database and the cluster up and running. We will see how it all connects in a second after installing this part. So let's install Traefik. So I'm just going to call this Traefik. We don't need all these MLFlow settings. Traefik is much simpler. And let's take the repo URL from here. Cool, so that should install Traefik. And now we want to make sure that each request, let's write it. Make sure each request that starts with /MLFlow is routed to MLFlow, is routed to this thing that we installed here. To route things on Traefik, I've created another component. It's pretty useful, and we use it a lot in Aporia. It's called Traefik Route. So let's copy that. And basically, what it does, it allows us to make sure that all the URLs that starts with a specific prefix goes into the relevant application that we will configure in a second. So this is the application. Again, all of this is completely open source. With the route. By the way, this is a cool trick in VS Code. You can click Control D and then write things concurrently. Yeah, so, okay, so let's use that. Let's route /MLFlow to MLFlow. Let's call this MLFlow Route. Again, this is just a Pulumi resource. So everything that starts with /MLFlow, we want to route to the MLFlow application, to the MLFlow service. Cool. So one last thing before the Pulumi app and actually seeing MLFlow live is that we need to make sure that ml.aporia.com, which again could be any other domain, is routed to Traefik. Okay, so we want to make sure that this domain, this public domain, is routed to this Traefik. We want to add a DNS record. Yeah, so we use in Aporia, we use Route 53, which is the yeah. So Route 53 is again it's it's AWS DNS provider for domain. So let's Google how do you do that in Pulumi, just like we did any other thing. And by the way, this is completely different between different domains. So this is just what we use here. Okay, so let's call this our DNS record. And we want to route ml.aporia.com, the CNAME. And we want to, use our zone ID. So this is pretty internal, but again, this is really different between different domains. Yeah, and now we need to configure this service, this Traefik service. So let's do that. So same way I got the service from MLFlow, I'm just going to do that in Traefik. And then we want to get the public host name of this Traefik. So we do it like this. Okay, so cool. So basically, this should be it. Let me see if I missed anything. Okay. Okay, so let's run Pulumi app. And since we already created this cluster and already created this database instance, it won't create them again. It will know that they already exist and use them. But it will create this artifact storage and install MLFlow and install Traefik and this Traefik Route and all the new code that we just added. So this will take a few minutes as well. And I think this is a good time for questions, if there are any.
Otherwise, I can sing a song. Waiting for Traefik to install.
Sorry?
Nothing. You're in the zone. I don't want to distract you. I don't want to put you on tilt. I love what you're doing right now.
Yeah. So in DevOps, there are a lot of things that can get you out of the zone.
Yeah. You need to stay in that zone. I like what you're doing. We've got a question coming through. How does Pulumi keep track of the current state?
Oh, this is a great question. So Pulumi actually, let me show you if I can show it to you. Yeah. So basically, okay, I'll just give it a quick overview. Just Pulumi basically maintains a state, and you can define Pulumi where to store that state. So you can, for example, store that state in an S3 bucket. You can store it in a local file if you're doing local development. What I'm using right now is Pulumi cloud services, like their hosted version. And the state is served there, but like Pulumi is completely open source, so you don't have to use their cloud, which does, I think they have a community edition, but the cloud version does cost some money. Does that answer the question?
I think so.
Okay, great. Okay, so while this is running, I think I saw that we had this error here. For some reason, I can't see the error, but we'll keep. But it's still running, so let's wait with that. Okay, so let's do a quick recap on what we did so far. So we created a Kubernetes cluster. We created an artifact storage, a place where we can store all of our models. We created a database which will store the metadata, the metadata for the models, the metrics, etc. These two databases will be used by MLFlow, which is what we're going to use for experiment tracking and for saving the models. Then we install Traefik. Right? Traefik basically exposes MLFlow to the internet. We're later going to use it for these models as well. And the next part is to actually create the model template. The model template the data scientist can clone and create their models. So let's do that. Let's see how it goes here. We had an error. Let's see if we can fix it real quick. I promise there will be bugs. Let's see. Zone ID. Zone ID. Oh, I think I have a problem with this environment variable. Just one sec. So this is just something that we can make sure that we can create this domain. So let's run that. This should be really quick right now. Yeah, so let me, while it's running, let me explain a little bit about how we're going to create that template. So I'm sure all of you are really familiar with Python and piping, but I'm going to use a pretty cool tool that's called Poetry. Yeah, not poems. That's right, Poetry Python. Yeah, so Poetry is basically a tool that helps you create a virtual environment for your Python packages. So I can do Pulumi init, and I can add packages, and all of this is encapsulated in the Pulumi, in the Poetry package. So, for example, if I have this model and I install lots of libraries, and then I send it to my friend, then all he will need to do is to run Poetry install, and that will install all of the required packages in a virtual environment. So that's pretty cool. I'm going to use that to build our model template. Okay, so it's currently creating this record. I just want to show you how MLFlow looks like. So let's wait for this. Yeah.
While we're waiting, I have a quick question because I know this has come up in past meetups, especially around MLFlow, and it's the difficulty of managing dependencies. If you're using a few different tools like you are now, how do you go about it? Is Poetry, I imagine it helps in that regard, but how do you make sure that all your patches are up to date? How do you make sure that all the dependencies are supported?
Yes, so this is a really good question. And I think this area of dependencies is pretty hard in general. So Poetry helps a lot for Python, but you still have things like your operating system dependencies and stuff like that. So we're going to use for serving models, like in production, it's super important that you always have a really deterministic environment. So we are going to use Docker for serving those models. And we basically, I'm not sure if we'll do it right here in the session, but if I would build, a real ML platform, then I will make sure that every installation, whether it's Helm or apt-get or Python packages, every package is versioned. So for example, here I would do something like for each package, I will make sure there is a version parameter. It's super important. Yeah, so does that answer the question?
Absolutely.
Cool. Okay, so I see that our Pulumi is finished. So I really hope it's going to work. So ml.com/mlflow. Please, 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 please.
Cross our fingers.
Yes. Okay, so we have MLFlow. So just to recap, we have this Kubernetes cluster, and we have this MLFlow running on top of it, and we're exposing it to the internet via Traefik, and it goes and it's I've done all that. Cool. So we have MLFlow. Let's start by building the model template. Okay, so I'm gonna clone this repo. Just as a reminder, we have two repos. One repo is for all the infrastructure, the shared infrastructure, Kubernetes, MLFlow, RDS, all that. And the second repo is for the model template itself. Data scientists are gonna clone this template build models on top of it. So let's build the template that they are going to use. Let's clone the template. Okay. So, okay, so let's create a new poetry package. We will call this my model. So basically, we're going to use the name my model for now, but later on, we're going to convert it to a real template that when you create a new project from this template, then you can like tell Cookiecutter what's the right model. We'll see that in a second. Okay, so we created a new poetry package. As you can see, we already have the SRC directories and some empty tests and so forth. And poetry has this file, this PyProject file, which contains the name of the package and the dependencies with all the versions of those dependencies. So let's copy our training code. Let's copy our data set first. So again, this is just a simple data set just to show how it works. But of course, you can use anything here. So this is the iris data set. And we have the train.py. Okay, so we're going to divide our model package to two packages. So we're going to have a training package, which is going to be the training code, and we're going to have a serving package, which is going to be the serving code. And we probably want also a common package for like shared pre-processing and stuff like that. So this is really random. And when creating this in your organization, it's really important, again, to think of the problems and what's the best structure for your models. But I'm just going to go with this. So every package in Python needs this file. We also need, okay, and we're going to have this train.py file. And yeah, all it does is like it imports like GBM. Again, this could be in different libraries. It reads the data set, it runs a really, really simple model, and then just evaluating it. Cool. So Poetry provides a really cool feature that allows us to run the training code, for example, in one command. So let me show you how it's done. I go to this PyProject file, which is Poetry file, and I'm gonna copy this section and call it scripts. So this section is going to have useful scripts that we're going to use. So one useful script is going to be train the model. So we'll need to write the path of this train.py file. So it's SRC, my model, training, train. And we want to call the main function in this file. Okay, cool. So now when we run poetry run train, it should train a model. Let's see if that works. Cool. So a lot of live GBM warnings, but it worked. Cool. So the next thing that we want to do is to integrate MLFlow into this training code. Let me show you how it's done, and then we are going to see this model back in MLFlow, back in the MLFlow dashboard. Okay, so I'm going to import MLFlow and MLFlow.liveGBM. MLFlow supports XGBoost and TensorFlow and many other libraries. And I'm going to enable a thing called auto-login. So the idea is that everything that I do here, for example, when I train the model, it automatically logs to MLFlow, which is pretty cool. So GBM.autolog. And I'm also going to set the tracking URI to our MLFlow server. So it's going to be this. So this is the path of our MLFlow server. And now, cool, so this is the initialization. Now we're going to create a new run. I have a problem with spacing, just a sec. Okay, so let's start a new MLFlow run. Basically, MLFlow run is like each time you train your model or do an experiment, it creates an object in MLFlow called run. So this essentially creates a new MLFlow run. Cool. And now I also want to, in MLFlow, you can also log some custom metrics. For example, I can do MLFlow metrics. And let's log the log loss and the accuracy of the model, just as an example. And we also want to print the run ID of this run. So let's do that. Run ID is going to be run.infra.run-id. Cool. So that should work. Let's train the model. And let's see if it's going to create a new run in MLFlow. I hope that works. That's the first page here. Yeah, and here's our run. It's not finished yet. Let's do 2 scans. Actually, it doesn't look so good with 2 scans. I'll just. So now what it's doing right now is to upload the model to MLFlow, and we got this run ID. So now let me show you the training experiment in MLFlow. Yeah, and we have all the metrics. We have our custom metrics here. We have the model itself. And again, this model comes from the S3 bucket that we created in Pulumi. So that's pretty cool. We can download the model, for example. Yeah. Okay, so that's basically training. Let's start writing. So let's do a quick recap on what we did so far. So we set up a Kubernetes cluster. We installed MLFlow on top of it, which uses this artifact storage and model metadata. Yeah, and we started to build our model template. The data scientists will clone and use it to install their own, to build their own models. And yeah, so that's basically what we have so far. So any questions before I continue to the serving part?
I'm not seeing anything coming through here. I have a question. I know that a lot of people in the last engineering labs that we did, which just shameless plug, if anybody doesn't know what the engineering labs are in the MLOps community and you want to get hands-on experience doing MLOps stuff like this, check out the channel in our Slack. And so I know in the last engineering labs, we used MLFlow and we also had PyTorch. Are you planning to do any specific stuff with the different frameworks?
No, you mean with the model template? Or?
Yeah. Can we use PyTorch? Can we use TensorFlow?
Yeah,
Is there anything?
Absolutely. Yeah. So you can use any library you want here. This is just a template that, You can change completely and do whatever library you want. It could be PyTorch, it could be Keras, it can be XGBoost, it can be a tabular data model, it can be computer vision or NLP or speech. So it doesn't really matter. So,
Nice. Perfect.
Okay, so let's continue to the serving part. So what we want to build right now is basically a FastAPI server, an HTTP server that once we do HTTP post to it, so HTTP post / predict with the parameters of the model, it will make a prediction and return the response. Okay, so in the serving part, let's start writing this package. So we have the init.py file, and we have our main file, which will start the FastAPI server. And I'm just going to Google a FastAPI example, just copy an example from the internet. Just copy that. Cool. So I'm going to need to install dependencies. I think I didn't do that in Poetry. So I've actually pre-prepared a command for that, just not to waste time on that. Let me copy paste it. Yeah, so this is going to install pandas and LightGBM and Matplotlib and MLFlow and FastAPI and Uvicorn, and we have a DVC, which we're going to cover in a few minutes. And this is, I don't know why I needed to specify the version here, but I think it's basically this library is like the AWS library for, it will allow us to, to pull and push files to S3. To make it work, I needed to make the version explicit, but it doesn't matter that much. So let's install this. And cool, so we will need a main function so we can run it easily. So let's see. Yeah, so I'm gonna use Uvicorn. Uvicorn is basically a library that allows that runs FastAPI servers and other kinds of servers really, really fast. I'm just gonna use it. We want to listen on all IP addresses, and for debugging, we want to use port 8000. So let's make sure to run this function. Cool. So the first thing that I want to do is to load the model from MLFlow. So let's import MLFlow, and let's load the model. So we want to do something like this, MLFlow.lightgbm.load model. And now I can provide a path in MLFlow. So let's go back to MLFlow. Yeah, so this is the run. This is our run. I can copy that. So this is the format that you can put here. So I'm going to use a static run just for debugging, and later on I'm gonna make this completely dynamic and everything. So this is just for testing. So we have runs. This should load the model. Now we want to make an actual prediction. To make an actual prediction, we will need the parameters of the model. So let's look back on the data set again, just to remind ourselves. So let's close some tabs here. Yeah, so let's look on the data set. Basically, we're building a very, very simple model that's classifies as flowers, and we have like the two parts of the flower, the staple and the petal. And for each part, we have the length and the width. So we want to have this JSON format that we will pre-process into a data frame and then make a prediction. So let's do that. Yeah. So let's go back to the FastAPI example to see how we're getting parameters from the request body. And basically, this is the idea. You define a class at the model of your parameters, and then you get it as a param to the function itself. So if that wasn't clear, it will get clearer in a second. Okay, so we first want to have a model for the flower part. We have with we have width and length. And we have two flower parts, so let's call this predict request. And we have the staple, for each part we have the flower part size, width and length for each part. And we're gonna need this parameter. Cool. So let's do it this way. So when we have a post request in /predict, then we want to make the actual prediction. So first of all, we will need to pre-process and create a data frame. So I'm just gonna do that in a second. Just want to give the big picture first. Later, I want to make a prediction. So we have y proba equals model.predict. And if you're not familiar with IGBM, you can just Google that later. Cool. And then we want to take the class with the highest probability. Highest probability is just argmax and yproba. I will need I will numpy, and I will need pandas. So let's convert that to an int. Cool. So, and then let's return that. So the flower is, this name is too long. Let's just call it flower. Okay, so let's write this very simple pre-processing code. So let's get a new data frame, which is going to have just one row. We have the columns of the data frame, and we have data. And again, we're just going to have a single row. Yeah, so let's copy the name of the columns, and let's use them from the request. So we have request.sql.length, request.sql.width. Let's copy paste that for the other flower part. Yeah, so this should be a really simple HTTP server. And just like we have a poetry run train, we also want a script for serving. So let's do that. Let's create a script for serving. So instead of train, we're going to have serving and main. Okay, so let's see if that works. Let's run the serving code. We have an error. MLFlow Run and another not found. Let me see what's going on. So this is the run itself. Let's just make sure I copy this correctly. Oh, okay. So I need to configure. So the serving code, in the training code, I actually defined the URL of MLFlow, but in the serving code, I don't have it available soon. So just as a quick spoiler, we are gonna convert this FastAPI server into a Docker container and install it in Kubernetes. So it will get this variable from an environment variable. So let's do that. So this is just for testing. Later on, we'll have it in a real environment variable. Let's see if that works right now. Okay, it's running the server. Okay, so we download the model from S3 and ran the server. And let's try to make an actual prediction. So this currently runs on localhost. And we have the width and the length of each flower part, and we have this result right here. So yeah, what we could do is to, it's to convert this number to the real name, but that's not the part of the session. That's not, the focus of the session. So I'm just gonna skip it right now. And okay, so the next thing that we want to do, let's go back and do a quick recap. So we wrote a FastAPI server that loads the model from MLFlow. And what we want to do right now is to run this FastAPI server in Kubernetes. Up until now, we just ran it on my local computer. So to run it on Kubernetes, the first thing that I will need to do is to create a Docker container from that. So this part, I'm gonna go really fast. I've already prepared the Docker file. This is, again, completely open source. Let's create that. Cool. So this essentially installs some dependencies, copies the poetry files, install all the poetry dependencies, and then run the Uvicorn server. So that should run the server inside the Docker container. When we run the model in production, we don't want to use a constant MLFlow Run ID. We want it to be dynamic. So we are going to load it from an environment variable as well. Do that. MLFlow Run ID. Cool. So that should give us the run ID from the environment variable. And now we are going to, okay, so we have this Docker file that runs our serving application. And additionally, we want to have a makefile for common commands like training and deploying the models. So let me explain about it right now. So what you're going to build is basically a CI/CD pipeline. Basically, each time that you're going to push to master, the data scientist will push to master, then it will deploy the model to our ML platform. So this is a makefiles. We have 3 commands. The first command will install all the dependencies of the project. The second command will train the model. And the third command will deploy the model using Pulumi. So we are going to create a really quick Pulumi infrastructure for this model specifically. So basically what it does is to train the model and extract the run ID from that model. And again, this can be completely customized to your needs. So that's the idea here. Okay, so let's work on our Pulumi package. Cool. So just let's do a quick recap. So we have the dev environment, and we have the general ML-Infra repo, which contains all the shared infrastructure for our ML platform. We have this EKS and S3 and all that we talked about. And now we're building the model template. We built a FastAPI server, and now we want to build a small Pulumi application that will deploy this model to the Kubernetes. Does anyone have any questions so far?
We're looking clean.
Okay, I'll give you just a few seconds. Okay, let's continue.
I'm wondering, I know that you had mentioned before to use Sheldon core, but you chose FastAPI. Was there a reason that you wanted to go with one over the other?
So basically there are a lot of options. There are tons of options how to deploy models. You have KFServing, and you have Cortex, and you have Sheldon core and TF-serving, and many different methods. So the reason I chose FastAPI is just because I think it's a little bit easier to customize. But Sheldon core is pretty good, as well as KFServing. KFServing is also really good. So when you build your own ML platform, you need to evaluate those tools and figure out what's the best one for you. But I figured out that for this workshop, FastAPI-based server is going to be pretty good. Okay, so let's continue. So let's build the Pulumi infrastructure for the model template. This infrastructure will upload the Docker container to Amazon and then deploy to our Kubernetes. So let's do that. I'm going to create a new infra repo, infra directory, sorry. And I'm going to create a new project here. I can just run Pulumi new. So again, just if you're confused, we have two Pulumis. One is for the shared infrastructure, and now we are building the Pulumi for the model infrastructure, specifically the model itself. So let's call this my model infra infrastructure, our ML model. So this creates a new Pulumi project. So we have infrastructure here right now. So we remove that directory. It's not relevant. Okay, and what we want to do right now is to deploy a new, deploy this FastAPI server to Pulumi. So to do that, I'm just gonna Google Pulumi, deploy Kubernetes apps on AWS. Just gonna copy, I think, this one. Deploy Kubernetes apps, actually. Yeah, I think it's this one. And this just gives us an example of how to build and deploy applications to Kubernetes, Docker containers to Kubernetes. Just gonna copy paste the code. And I need to install some packages. Let's make sure, let's do that here. I want to make sure that all of these packages are installed. So we need this and this one, AWS and AWS 6. Cool. So so the first thing that we want to do is to build and push the Docker image, like the FastAPI Docker image, to AWS. So this is how you do it, basically. I'm gonna call this repo like this image. The name of the image, I'm just gonna call it my model. And then basically that builds and push our Docker image once we do Pulumi up to AWS. Cool. So the next thing that we want to do is to to create to connect to the Kubernetes that we previously created. We don't want to create a new Kubernetes. We want to connect to the previous one that we connected. So Pulumi provides a way to read different Pulumi projects. So let's do that. So what we're going to do is to do something like this. We have the base stack, and I can do a stack reference. So let me do something like this. So what I'm doing right now is simply to reference to the previous shared infrastructure. So I will get access to the Kubernetes. Reference, and it's gonna be on. I think it's in my project. I think that should work. And then we want to connect to that Kubernetes. So it looks like this. So let me explain what I did here. So let's open the ML-Infra on two screens. Okay, so the left screen is the ML infrastructure, is it's the generic infrastructure, and on the right screen we have the specific infrastructure for the models. So we created a Kubernetes cluster here, and in the end of the file we exported the kubeconfig, which allows you to connect to the cluster. So in the model template, I can reference that variable. So I am referencing the ML-Infra Pulumi project. And I'm getting this. I'm running get output on kubeconfig, and that reads the kubeconfig of the cluster that we created. Was that clear? It's a little bit complicated.
was good for me. I'll let anybody else chime in case it wasn't so clear. In the meantime, there was a question that came through about if you can give us a quick example of how Triton inference server would fit on this infrastructure.
Yeah, sure. So, yeah, exactly. Okay, so right now we are, have this ML repo and we have this model template, and we are deploying our FastAPI servers to the Kubernetes, that we created in the ML-Infra project. So if you want to use Triton inference server, so if I'm not mistaken, Triton inference server, I'm not really familiar with it, but I think it has Kubernetes CRD, right? Custom resources. It creates custom resources on top of your Kubernetes, if I'm not mistaken. So you would install Triton inference server on your shared infrastructure. You would install it here. And then instead of deploying FastAPI servers, you would just deploy Triton custom resources. But again, I'm not really familiar with Triton, so I can, if you want, I can check this later and get back to you on that for sure. But in general, it looks something like that. That's true for KFServing and Seldon Core, and probably for Triton as well. Cool. Okay, so, okay. So so let's continue here. So we have this model template, we have this provider. Let's build our let's deploy our FastAPI server to Kubernetes. This is the image that we just built and pushed. This is the port that we are exposing from the service, and we will need to specify the run ID and the tracking URI of our MLFlow. So let's start by MLFlow tracking URI, and I'm going to just give it a constant value. But again, this you should probably take it from your configuration or something. And the MLFlow Run ID, which is the MLFlow Run that we're going to sell, we will use Pulumi config for that. So Pulumi has inputs, which is what I'm going to do right now, and outputs. This is an example of output of Pulumi. So let's just configure that, and let's just get the run ID from the Pulumi config. So let me show you how that works. Okay, so we are going to have a CI/CD pipeline. Each time that a data scientist pushes something to master, it will run this make file. It will run specifically the deploy. It will run make deploy. Make deploy will configure the Pulumi stack. It will train the model and extract the run ID from it, and then put this run ID inside the Pulumi config. And then we reach here, and this will set up our model serving infrastructure using this run ID. So I hope this is clear. Cool. So after we have this pod, we can create a deployment for it. By the way, if you want to scale this model, you can do something like that. You can just add more replicas. I'm just gonna take it this way. And the next thing that I want to do is to create a service from this deployment. So this is the Kubernetes service that we're going to route to this model. And we are going to, just like we routed Traefik, like we routed MLFlow to Traefik, we are going to route this model to Traefik as well. So if we're going back to our infrastructure, so we have this FastAPI server that we are deploying on Kubernetes, and now we want to expose those through Traefik to the internet. So I will need my Traefik route component, the open source component. I'm just going to copy it from here. Copy paste it here. Cool, and let's copy the Traefik Route code. Okay, so we need to import that. Route. Okay, so this will be my model route. So we're going to serve this model in the following URL /model/my-model. So this is the service, and we are using the cluster that we just referenced to. Okay, so let's recap. We are currently writing the model template. We're building the FastAPI server that are going to run on top of Kubernetes. And these servers are actually going to load the model from MLFlow, which is going to load the model from S3. But we do need to make sure that this FastAPI server have access to the S3. So we're going to create another S3 user, another service account that is read-only. You can only read, like these servers can only read models from this storage. So let's do this in our shared infrastructure. So just like we created a service account for MLFlow that is not read-only, we will now create a service account for models that is read-only. Yeah, and let's expose the name here. So this is going to be model service account name. Cool. So let's run Pulumi app so that it will create this user. And now we want to actually use this service account here in this pod. So let's do that. This is the service account name, and we will extract it from the ML-Infra stack. This is get output, model service. Okay, so that should be it basically. Let me also copy the GitHub Action. GitHub Actions is basically what we're using for CI/CD. We have it here. We are going to have it here. Again, all of this is open source. Yeah, so let's reopen this page. And we're going to create a directory called workflows here. And yeah, basically, let's explain what it does. So basically, on each push to the main branch, this is going to run to install all the dependencies using our make file, and then run make deploy in order to deploy the model, in order to run the Pulumi, which will in turn deploy the model to the Kubernetes. Cool. So let's see what's going on here. It's already creating all of this. And right, okay, so it's done. And now we are going to push. I think I have a small problem here. So this is the repo. So the GitHub Action should be on the root of the repo. Just a small mistake. Okay. So let's commit right now. Let's create a commit. And then we should have this deployed to our platform. Okay, so we will need to add a git ignore because a lot of unnecessary files. Let's refresh here. Okay, so let's push that. Initial commit. Cool, and that should actually let me show you how it works. So we have the model template. Yeah, so right now I actually pushed directly to the main branch, to the master branch. And just to make sure, in real life, what you would want is probably, you would want a pull requests and you want code review on every change to the model. Right now, I just push directly to main, and this runs the GitHub Action. So let me show you what it does. So first of all, it installs all the dependencies of Poetry. And the second thing is to deploy the model. It simply runs the model. It creates a new experiment in MLFlow, and then deploys a FastAPI server that uses this experiment. So this will take around 5 minutes. And in the meanwhile, we could do a quick recap. So we have our FastAPI servers, all of this. We're exposing them through Traefik. We have the MLFlow, the artifact storage, and model metadata. And we're pretty close to finishing. So the next thing that we want to do, and this will be the one before last, is to create, is to use DVC, is to create, a storage for data versioning. So to do this, I'm gonna, just like I created an S3 bucket for the artifact storage, I'm gonna create an storage S3 bucket for the data. Let's call this data storage and data storage, and let's run Pulumi. So this should simply create a new S3 bucket for the data. Cool. So let's see. Oh, we have an error here. So what's going on? Oh, I didn't install a dependency. So let's make sure to install it. Otherwise, it won't work, of course. Yeah. So let's go to my model/infra, and let's install this, and just to make sure that we have everything that we need. So we won't get any errors. Let's install all of this as well. Okay, so this will just take a few seconds. And let's commit again so that it will work this time. Yeah, so we're missing those. Dependencies. Cool, and now it's running again, so we will be able to see the GitHub Action in the second running. And in the meanwhile, I'm gonna set up DVC. So right now, until now, I've actually, so this is the model template, and we have this data directory where we put our iris dataset. But in this example, we would want to store data not on Git, but on DVC, because DVC is much better with large files and datasets. So let me show you how that works. So I'm gonna cd to the data directory. This is the data directory, and I'm gonna initialize DVC in this directory. So DVC init subdir. By the way, since DVC is installed inside the Poetry virtual environment, then I need to run Poetry Run before the command itself. Okay, so this will create a DVC repository in this directory. Now what I need to do is to add the S3 bucket that I created, the S3 bucket that I created for DVC, well, I need to add it as a remote. So let's see what's going on with our DVC bucket. It's actually, it was created, but I just realized that I forgot to export its URL. So let's do that. So this is going to be DVC bucket URL. So exactly the way we did it for MLFlow. We're going to export the data storage here. Cool, and let's run Pulumi up again. So we're going to have the address of this DVC URL. Cool. So let's see what's going on with our model in the meanwhile. So we're doing a lot of things in parallel because I only got 10 minutes left. But basically what we're doing right now is spin up DVC to set up DVC. This is on the infra part. And on here, we are deploying the model to Kubernetes. The FastAPI server that we wrote, we are deploying it to Kubernetes. So let's see. Does anyone have any questions so far? I see Demetrius is out, but you can write me in the chat and I will take a look. Just waiting a few seconds. Okay. So let's wait for this to finish. Take a few seconds. Okay, so now it's going to deploy the model. It's going to train the model. And we already have a run ID. We can already see the run in MLFlow from the CI/CD pipeline. So this is GitHub Runner. This is the model that we trained in the CI/CD and GitHub Action. And right now it runs the Pulumi, which will deploy the model to the Kubernetes that we created. So let's wait a few seconds. Yes, it's compiling. I think what it's doing right now is to compile the Docker image. See, it's running Poetry install. So let's continue giving it some seconds. And meanwhile, we have now the bucket URL of DVC. So let's continue on that part. So we initialized a DVC directory in the data directory of the model template. Let's add the remote. Let's add the S3 bucket as a remote to the DVC. So I'm going to run Poetry run, DVC remote add. We need this flag. We want it to be the default remote, so -d. And we give it a name. We're just going to call it S3. And this is the address of our S3 bucket. So again, DVC is what we use for data versioning, and it's going to save data sets in this S3 bucket. So cool. So now we have DVC set up. Let's add our iris dataset to this DVC. Let's do that. DVC add iris.csv. As you can see, it's really similar to Git. It's very, very similar to Git. Okay, so I got an error. Okay, so DVC wants me to untrack this file from Git and then add it from to DVC. Okay, because I don't want the dataset to be both on Git and DVC. So let's just copy paste those commands. Should be like this, I think. Let's create this commit will actually remove the dataset from Git. And now we can add it to DVC. So Poetry run add, DVC add, iris.csv. Cool. So for each dataset file, CSV or Parquet or whatever, DVC will create a small file in our repo that's called iris.csv.dvc. And this is just like the hash of the file. So this file we do need to commit. So let's commit that. And finally, I need to push the dataset to DVC. So running DVC push, and this will save our dataset in the S3 bucket. Cool, so let's see what's going on here. It should finish in a second. Usually takes around 5 minutes, I think. So let's go to the end of this file. Okay, so we already have the Kubernetes deployment. Like it's already created. It's now probably downloading the Docker file or something. So let's wait a few seconds here as well. Okay, actually, yeah, so looks like the deployment is now finished, and now it's trying to direct traffic to the pod. Okay, I think it worked. Okay, very cool. So let's try. I really hope this is going to work. let's try to access our model. So ml.aporia.com/models/my-model. Okay, we have an error. Okay, so I think we only have 5 minutes, so I want actually, check what is this error, but it should work probably some technical reason. Yeah, so this is actually DVC. And in our last 5 minutes, the last thing that I want to show you is how to we just built a model called my model here. And the last thing that I want to show you is how to convert this to a Cookiecutter file, a Cookiecutter template. So let me show you how it's done. So I'm going to Google an example of Cookiecutter. Yeah, and Cookiecutter is basically a really simple tool that allows us to create templates for things. It could be model templates and other things. So let's create this template. So each Cookiecutter template has a JSON file that looks like this. We're just gonna copy it. Cookiecutter.json. Cool. So let's remove all of these. We don't need them. Let's call this boilerplate code for ML models. And as you can see, there are some variables here. Last name. These are the defaults for the templates. We don't need the GitHub user. And the default name will be just my model. Yeah, so we have this template here, and the idea is that I can now change the name of this directory to cookiecutter.project/. I'll use model name actually. And that's not permitted, but let me, since we're really out of time, I'll just explain it. What I'll need to do is change, for example, the directory instead of my model to this variable here. I can also use those variables inside of the code itself. Exactly. So this is the open source project. This is going to be the open source project. So we have this this template, and as you can see, we have the my model directory, which is not my model anymore. It's this variable right now. And we have, and also in the code itself, you can, let me show you that, you can use, actually it's not here. In the code itself, you can also use Cookiecutter parameters. So this is an example. So Cookiecutter will know to replace that parameter. So let me show you how it works. This is, for example, the template for the data scientist. So let's say I'm a data scientist and I would like to start a new project. All I need to do is run Cookiecutter, this GitHub repo, and then it asks me some questions. My name. I can call this a fraud detection model, for example. And this will create the model in using this template. And then when I push it to GitHub, it will automatically be deployed to our ML platform. Okay, so basically that is it. Let me just go over what we didn't do today. So we didn't do a lot of stuff. So we didn't configure HTTPS, which is obviously really important. We didn't configure authentication, like it's just public in the internet right now. We did not configure environments like staging and production and stuff like that, which is usually good practice. We didn't create a common library for pre-processing and post-processing and other functions that you might have, same for Pulumi. We don't have, in this really small ML platform that we built, we didn't implement model validation or input validation, which is, of course, super important in production. We didn't show how to do Git flow, pull requests, etc. So we can do all this in a a different session. But I think the point that you can simply, take all those tools and play with them and build your own ML platform. Yeah.
This is awesome, man.
Thank you.
I have one final question. I see that there's all kinds of people saying that this was very useful in the chat. So thank you so much for doing this. I'm wondering about the use of DVC with MLFlow. And it seems like they used to be very complementary, but they're kind of going into each other's space a little bit, especially with CML. How do you decide what you want DVC to do and what you want MLFlow to do?
Yeah, so I think, to be honest, I don't think I'm going to have a really good answer for this question, because it really depends on, it really depends on your needs, like what you want, like what are your problems. And if you have, for example, a problem regarding data and you have data scientists that know Git, so DVC might be more appropriate. So it's really like, there are a lot of tools, there are lots of parts that are common between tools. And you just need to deeply take a look on your problem and your people and everything, and figure out what's the best tool for the job. And also, don't be afraid to deploy, to use a tool, to start using a tool, and then replace it to something else. It happens a lot.
Awesome advice. Well, I thank you so much for this. And I see a lot of people are saying they're looking forward to recreating it and reproducing it. We will add the video, this whole video, we'll put it into our YouTube channel probably Friday or Monday at the latest. And we'll throw all the links to everything that you were using in the description there. And that's about it. Unless anybody has any last minute questions, we're going to finish it here. Thank you all for joining us. And thank you again, Alon. This was absolutely amazing. I learned a ton. It looks like everybody else learned a ton. You were awesome, man.
Thank you.
All right. See you all later.
Okay, bye-bye.